like. Okay, so did the review, and hopefully I can get it done, because that'd be great if I can get it done. And that way you guys have the review. Okay, so number one is identical to our warm-up. I did that on purpose. Same one. We know that the only way we can get an answer of x minus 4 is if we have an x plus 4 equals 0 as one of my factors.
Can I get a pretest, Mr.?
Right here. Right here. Okay. And then the only way I can get an answer of 2i is it had to come from a square root. So it had to have an x squared equals negative 4, because I take the square root of that would give me plus or minus 2i, which means it would have come from a factor of x squared plus 4. If I had an x equals the square root of 7, it would have had to have come from an x squared equals 7, which meant it would have had to have had a factor of x minus 7, x squared minus 7. So then my polynomial, and it's a general polynomial, would be x plus 4 from the first factor, and x squared plus 4 from the second factor, and an x squared minus 7 from the third factor. Okay? All right, so that is number one. And it's identical to what we did in the warm-up. Okay? All right. Okay. Slide it up. Oh, well. Right there. Thought I put it on your desk. Yeah, you can do that. This is not hard, is it? No, number 2 is super easy also. Okay, number 2, we're just going to add like terms. So in number 2, I've got a 10x cubed and a 4x cubed. It's going to make a 14x cubed. I have 18x squared, and a 3x squared is just going to make a 21x squared. I'm going to have a, let's see, I need another color. Give me another color. Give me another color. Oh, green. There's green. Got green. And I got a negative 4x and negative 6x just makes a negative 10x, right? That's all I have to do, because it says add. Yep. It says add. And I just added. Be careful. If you see the plus, if you see plus, be careful. That right there means just add like terms. Add like terms. Okay? So that's the answer I got for that one. How am I doing? Yep. Good. Well, we've been doing this, haven't we? So this is a chapter test. And a lot of this stuff you know because we've been doing it for like a couple of weeks, right? Maybe longer. Maybe longer. All right?
Wait.
Yes.
One more second.
Okay. Lucy, give me thumbs up when you're ready.
Ready.
Okay. I don't want to go fast. You guys know that. So you can stop me anytime you want. My goal is to get you to understand it, not to confuse you, okay? All right, let's take a look at number 3. Now, number 3 is unique because of the subtract, okay? So I'm going to try and highlight that. If I have to subtract terms, you can, but you have to be careful. What I like to do is I like to subtract all of this and then add. So for me, it's easier if I bring the negative through first. So I'm going to rewrite 3. I'm going to have an 8xy minus 15x plus 12y. But then I'm going to subtract 3x, subtract 5y, and subtract a negative 15xy, which is like a plus 15xy. Now I've changed the whole problem to plus because I added my negatives. So again, I'm just going to add like terms. All right? I've got a 8xy and a 15xy, combine those, make a 23xy. I'm going to keep combining like terms. I've got a negative 15x and a negative 3x makes a negative 18x. I have a 12y, and negative 5y is going to make a negative 20y. Thumbs up, you can do that tomorrow too, can't you? There's an awful lot of this you know how to do.
I don't think that's right.
Yeah, it's a positive 12y.
Oh, I made a mistake. Oh, you guys are so good. Yeah. Thanks, Juan. Me make a mistake. Me make a mistake never. Thanks, guys. Good thing there's a retake, huh? Oh, you guys are on 4 already, huh? Okay, you're on 4. So it's a big foil. It's a big, this times this, this times this, this times this, okay? Let's do that first. All right, number 4. So x to the 6th times x third is an x to the 9th.
Oh, you
Add x, we're going to add exponents. X to the 6th minus 4x, a minus 4x to the 7th. X to the 6th times a positive 3 is a positive 3x to the 6th, okay? Then, negative 1 times x and that. Negative 1 times x cubed is a negative 1x cubed. A negative 1 times a negative 4x, a positive 4x, and a negative 1 times 3 is a negative 3. Now, I am done. None of these are the same. Cannot combine like terms. That's my answer. So, before I move on, I really want to show you and emphasize this. When you're done, I want everybody to look. When you're done, look. See the plus? Is there a plus here? This one, you're going to do this, but you're not because you're listening. You're not going to go this times this, this times this, this times this. You're just going to add, correct?
Yeah.
And this one, you're going to multiply. You see the difference? Good, because a lot of kids will do all of this, and it's more work, and it's wrong, and it's like a bummer. Okay, 5, divide. So let's do synthetic division, correct? Which we're good at, right? Okay, so number 5, we're good at synthetic division. I'm going to take opposite, negative 3. Yep.
What if we don't finish this, bud? Do you have a video?
Yeah, I'll finish videotaping it. Yeah. Oh, there you go. Smart. Take a picture of it, okay? Okay. So, number 5, we're going to do synthetic division. Negative 3, right? Opposite, upside down. I am missing a term. I'm missing an x cubed, okay? Do you see that? We're missing an x cubed term, so I'm going to go 1 for the x to the 4th, 0, x cubed, minus 2x squared plus 2 minus 4.
Can you slow down?
Yep. Okay. Tell me when you're ready. So, I like to just I like the arrow, and the reason I do this is then no number goes here. Does that make sense? No number goes there, that's why I like to bring the arrow down. So, bring the first term down, 1. And then multiply. Remember this? You guys are good at this. 1 times negative 3 is a negative 3. And I add 0 plus a negative 3 is a negative 3. And then I multiply. Negative 3 times negative 3 is a positive 9. And I add. Negative 2 plus 9 is 7. And I multiply. I get 7 times negative 3 is a negative 21. And I add, and I get a negative 19. And I'm going to use my calculator. I think it's 57. Pretty sure it's 57. 3 times 19. 3 times 19 is 57. Yes, I get 57. And then I get a 53. It's not a factor, is it? Not a factor because of that. I needed an answer of 0, remainder of 0. So my answer is always 1 less power. 1 less power of the beginning. So instead of being an x to the 4th, 1 less power, it's an x cubed. So my answer is a 1x cubed minus a 3x squared plus 7x minus 19 plus my remainder, 53, over what I actually divided by, which was my x plus 3. Is it a factor? No, not a factor. It has to have a remainder of 0 to be a factor, okay? How am I doing? Okay. Yes, Madison.
Do we have time to finish this in class?
If not, I'm just going to keep, and I'll finish the recording 4th period, so I'll have part 1 and part 2, okay? Yeah, right? Yeah. Okay, you ready for me to? Okay.
Oh, hold up.
Yep, I will. I like how Sophia just takes a picture of it. So easy, right? Yeah, and you go back and finish it, right?
What is that?
Oh, 1 less power. So it had to be an x cubed, not an x to the 4th. Okay, all right, ready? Let's do 6. So 6a, we're going to factor, okay? 6a, we're going to factor x to the 4th minus 10x squared plus 9. Okay, well, what do you think? Yes, yes, 9 and 1 is totally right. How about an x squared, right? And negative 1, negative 9. Can we go again? Again, yes, we can go again. We can go again, yes, we can. We can factor those, both of those again, because it's the minus, it's the negative, right? If it's subtract, you can factor it again. We can factor that into an x plus 1,
Question.
x minus 1, yes.
So, is there, this is kind of different, but so there's not a square root of 4, but there is a square root of negative 4?
There is a square root of 4, but there's no square root of negative 4, because negative 4 would give me an imaginary number. You can't take square roots of negatives unless you allow I. No square roots of negatives unless you allow I. Yeah, Madison?
How does negative 9 and negative 1 equals negative 10?
Great, let's do our double smiley, right? Negative 9x squared minus 1x squared makes my negative 10x squared.
Okay.
Good question, Madison. Okay, and that is my answer to 6a. Let's look at b. Okay, so, yes. Okay. Juan, you had a question or you're just stretching?
No, I'm just stretching.
Okay. I'm going to write down b while you guys are getting ready for me, okay? X cubed, 2x squared minus 10x. Okay. Okay, there's 4 terms. So whenever I have 4 terms, I like to do it by grouping, right? So then the first 2 have a 2x squared in common. Multiple of 2, they both have at least an x squared in common, so I'll common factor out of 2x squared, okay? So I'm going to common factor out of 2x squared. What would be left in the 2 terms would be an x minus 1. Oh, 2x minus 1, my bad. The second group has a negative 5 in common. Negative 5 in common, and I'd have a 2x minus 1. This needs to happen in order to be able to factor this. I need to have these two be the same. They need to be the same to factor it again, and they are. So then I have a 2x minus 1 is what they have in common, and what's left over is my 2x squared minus 5. And that's it. Factored. Again, we've done this before, right? So it's a nice little review. of things we've studied before, okay? How am I doing?
Is there going to be more when you like show our work on the test?
Oh gosh, yeah, your test is 4 pages. 2 front back, 2 front back, 2 pages front back. And not that the test is that long, it's just
Space?
space.
Better be space.
Space, because I want to see your work, right? I want to see your work, okay? 7, you guys ready for 7? So 7 says find the zeros. All right, here we go. Now, 7A is the extra. So I'll come back to it, okay? That's the extra, or one like it is the extra. So we'll come back to it. 7A is the extra, okay? Because you're going to have to use the quadratic formula and all that, okay? But let's look at B, and I'll come back to 7A, all right? So B, we're just going to solve it. I've got a 2x cubed plus 5x equals 11x squared. I know I'm going to have 3 answers. I'm going to have 3 answers. I'm going to bring over the 11x squared so I can set it equal to 0 because I'm finding zeros. I'm finding zeros, so let's set it equal to 0, okay?
Wait a second.
Mm-hmm. Okay. I'm going to rewrite it as 2x cubed minus 11x squared plus 5x equals 0, okay? What do you see? What do you see? Mr. Daly, what do you see?
I see a lot of numbers.
I see it.
-5, -1.
There you go. What do you see? Do you guys see anything? That's completely correct. Common factor, let's make it easier. Let's take out an x. If we take out an x, wouldn't that make it easier?
Yeah.
2x squared minus 11x plus 5. Good. And there's only one way to make a 2x squared, right? 2x, x, right? There's only one way to make a 5. 5 and 1, but I got to be careful where I put them. Put my 1 here and my 5 here because my double smiley. That makes my 11. Doesn't that make an 11?
Yeah.
Can you see the 11? But I need a negative 11, so negative, negative, right? All right, now I'm not done because I need to find zeros. Well, that's easy. Mini equations, x equals 0. 2x minus 1 equals 0. And an x minus 5 equals 0, right? There's my mini equations. And I solve. Well, this one's already done. X equals 0 is done. Boom, one answer. Plus 1, 2x equals 1. Divide by 2, x equals 1/2. There's my second 0. Plus 5, x equals 5. And there's my third 0. And I'll let you get caught up. And then we'll do the next one, okay? Now the next one I'm probably going to need my calculator, right? But I might change the question. Because what I want, basically, I want you to do this without a calculator.
Oh,
Which you can. If I take these 2 questions and change, so I'm just going to change these 2 questions for tomorrow. Okay? All right. There's a lot. We can do this without. Okay? You ready? Let's do number 8. All right. Now, if I have to graph this without a calculator, it's like, are you kidding me, Mr. Davies? We can't do this without a calculator. Of course we can. Without decimals? Of course we can. Sure we can.
They circled the what values.
All right. So if I take a look at g of x equals x cubed plus x squared minus 6x, okay? I know this. I know it has to look like this. Okay, I don't know exactly, but it has to look like that. How do I know that?
That's X cubed.
Okay, now you ready? Before I go any further, on 8, do you agree with my shape?
We have to
Yes.
write that down.
Well, do you agree with my shape?
Yes.
Good, then don't write that down. As long as you agree with my shape, then let's get some things we need. So the zeros, let's find our zeros. Well, the zeros are easy. Okay. And what would you do? Can we make it easy?
Take out.
Yeah. And I got an x squared plus a 1x minus 6. Good. And then what? Yeah. X and x, and how about a positive 3, negative 3? You okay with that? Positive 3, negative 3? Positive 3, negative 2. I said it wrong. Positive 3, negative 2. Then our mini equations, we know that x equals 0, x equals negative 3, and x equals a positive 2. So all I need from you tomorrow is just this. I need the zeros. Well, we can get that without a calculator, right? And I know the shape, it has to look like this. I don't care about the y values. I just want to see if you understand that part of it.
Okay, so we need to draw the graph.
Yes. I know this heads off to positive infinity because why? Why does it end at positive infinity? Why? Because there's a positive x cubed, isn't it? If it was negative, it would just be upside down. Thanks, Caden. Does that make sense? So tomorrow, all I need is a shape and the zeros, and you do know what a cubic function looks like, right? All right, Madison, that was the right thing. So we will ignore this, and I will change that question, okay? Maybe I'll give you a graph, okay? Number 9.
Is this just what we're doing right now?
Can I see the graph again?
Yes.
Well, I'm just saying, like, this is crazy.
We've done it.
Wait, can you keep it right there first?
Yeah. Number 9 is what we did in our warm-up. Okay, number 4, do I need to do it? Want me to do it again or not? No, I don't need to do it, right? Let's just flip the page. And number 10 is what we did on the warm-up, but I'll do that one again because you were confused on 10. Because we did it on a warm-up. Right, number 4 in our warm-up. Exact same problem. I did that on purpose. It is, yeah. Number 10 is the exact same problem, but I think I should do it again, correct?
Yeah.
Let's do 10 again, okay? So 10, I have 3x plus 2y to the 5th power, and I want the third term, so it's a little bit different. This time I want third term, okay? Do you need graph paper? No, that's not, I don't know, that's not very good. What do you want? All right, so Valeria said 1, 5, 10, 10, 5, 1. Where did she get that? Whoa, where did she get that?
From the 5 squared. Wait.
From 5th row Pascal's triangle, right? And that's actually, I think, even in your journal, isn't it? I think it is. A5, A4, A3, A2, A1, and noise, right? B5, B4, B3, B2, B1, and no B's. I need the third term. Okay, I don't care about the rest of these. They don't matter. Just need the third term. Yeah, I tried to do this on purpose to make it a little bit easier. A is 3x, B is 2y. All right. So a lot of our work is gone. So we got a 10. A is 3x, so 3x cubed times a 2y squared. If you want to do this, I don't want to do this, but if you want to do this to make it easier for yourself, this might make it easier. What did I do? Would this make it easier for you?
No. I feel like the top one is better.
Yeah.
Okay, so I would agree with you. I would just go to 10 times 27x cubed times a 4y squared. Or you'd get the same thing doing this, wouldn't you?
Would you accept the first answer, or would you want it to be simplified even more?
I would take half off. I mean, I think it's worth a couple of points, so I wouldn't give you full credit. To get full credit, I'm just going to go from here. What is 10 times 27 times 4? 1080 x cubed y squared. That's what I want for full credit. But that wasn't so hard. I just used my calculator to multiply those out.
Say 1,080?
Yeah. I can't, you know the hard part, Sophia, is once it's recording, I can't change the size of it. Yeah, Madison?
When you multiply that out, the exponents just stay the same.
Because check, this is why I did it the long way. X times X times X, Y times Y, right? Yeah. Yeah. And that's why I showed this. It's kind of a pain, but it will get us the same answer, okay? All right, how am I doing?
Good, good.
All right, let's look at 11. I can probably do 11 on the side. We have room for 11 here. Okay, I have an x equals -2. That's that 0. I have it twice, don't I? X equals -2 happens twice. It's a double root. It's a double.
Oh,
I have an x equals 3,
that answers all.
and I have an x equals 6. So, and it has to go through the point 0, 3. All right, so here's what I know so far. Y equals some value a, x plus 2 quantity squared, x minus 3, x minus 6, okay? And I wrote this x plus 2 quantity squared because there really are 2 of them because of the double root. All right. Now I want the value of a, so I'll plug 0 in for x,
Oh, shit.
3 in for y's, okay? So I'm going to go my 3 equals a times a 0 plus 2 squared, 0 minus 3, 0 minus 6, okay? I'll have 3 equals a times, let's see, that's 4. That's a 4 times -3 times -6. Let's see, 72, right? No, 12, yeah, 72. Yeah, 12 times 6, 72. No, 12 times 6, yeah, 72. 3 equals a times 72. Divide by 72. Uh-huh. Mm-hmm. All right, 372s is okay, but I think it reduces. I'm pretty sure it reduces. Is it 24? Or 1/24 is A. So my answer, I'm going to take this and put it there. And my answer is going to be, Madison, let me write the answer down and I'll come back to your question, okay? Y equals 1/24 x plus 2 quantity squared, x minus 3 times x minus 6. Yes, Madison. Yeah, absolutely. I mean, absolutely will accept